Okay, last video in lesson 21.1, we're in 21-1C video right now, and we're going to be talking about how we can use the complement of an event to figure out the probability of the event itself. You may have noticed this in the last example that we just walked through with the broccoli, cauliflower, etc., that the probability of getting an event to happen plus the probability of it not happening. This is the fundamental rule of probability, if you will, that all the probabilities have to add up to 1. And so we can use this relationship that the sum of the probability of an event and the probability of its complement, or of it not happening, has to be 1. So if I want to calculate the probability, I can do that by taking 1 and subtracting the probability of the complement. Or if I want the probability of the complement, I can just take 1 and subtract the probability of the event itself. Why is this helpful? Well, if we go to the next page, so you guys, I'm on page 1088 here in example 2, and we're talking about how it is that we're going to use the complement to calculate the probability that they're asking me for. In this case, the probability in part A, we have a blue number cube and a white number cube at the same time, so a blue die and a white die, if you want to call them the the vocabulary. What is the probability that we do not roll doubles? Well, if we're looking at this sample space, you guys, over here, not rolling doubles is a lot of different values to calculate. So as you can see, what they've done is that they've given us kind of an oval here down the diagonal of circling the values where we do roll doubles, and then using the idea of complement to calculate the other probability of not rolling doubles. So here's how we're going to work this. First off, we're going to define the events. So A is that we do not roll doubles, and A complement is that we do roll doubles. We make a diagram, and we have this sample space over here that is encompassing all of our different possibilities. And then we're going to determine the probability of the complement. If the probability we're being asked for is a little too complex, we're going to determine the probability of it not happening. So if we count down this diagonal, we have 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, and 6 and 6 are what we call doubles. And that's 6 different possibilities out of the total of 36 in the sample space. So the probability is 1/6 of getting doubles. So in step 4, we're just going to use this relationship that we encountered on the previous page, that those two probabilities have to add up to 1. And so if we want the probability of no doubles here, we're simply going to take 1 minus the probability of getting doubles, which is what we just calculated. So that's 1 minus 1/6, or 5/6. And so the probability of not rolling doubles is 5/6. Let's look at part B. We have a pile of cards that contains the numbers 2 through 6 in red hearts and 4 through 8 in black spades. And each pile of cards has been randomly shuffled, and we're going to pull one card from each pile, and we want to know what is the probability that their sum, or the addition of the two cards' values, will be less than 12. So let's define our events. Let A be the event that the sum is less than 12, and A complement be the event that, let's fill this in, the sum is more than 12, or actually 12 or more. And you can also state that as not less than 12. So we're going to make a diagram. We're going to complete the sample space here. And I think it makes sense to just simply fill in with what the sum values would be. So instead of having 4 plus 2 there, let's actually do the calculation. So right over that, on top of that, is a 6. These are 7s. So 6 and 2 gives me an 8, 6 and 7, a 9, 8 and 2, excuse me, 6 and 2 gives me an 8, 7 and 2 gives me a 9, and 8 and 2 gives me a 10 in this column. And let's go down the next column. So 3 and 5 is what we need. That's an 8. 3 and 6 is 9. 3 and 7 is 10, and so on. So I hope you guys can see the pattern here going across in diagonals. We have the same sum as we go across these diagonals, so let's just fill in the rest of those values here. We've got an 8, 9, 10, 11, 12, 9, 10, 11, 12, 13, and 10, 11, 12, 13, and 14. Okay, so what I want to do is I want to figure out what is the probability of not getting a sum that is less than 12. So in other words, 12 or more. And I hope you guys can see that's these triangle of sums right down in the bottom corner. So that's 6 possibilities out of the total. And the total this time is 25 total possibilities in my sample space. Let's go back to our notation. Again, we want the number of items in the complement of the set out of the total. Now on the next page we're just going to simply do a subtraction, and this subtraction gives us the probability of A. So 1 minus the probability of A complement, which we just figured out was 6/25. With that subtraction is 19/25. Remember, we need to get a common denominator here, so this is like 25 over 25 is the value of 1. 25 minus 6 is 19/25. Okay, so the probability that the sum of the two cards is less than 12 is that number that we just calculated, 19/25. So let's use that idea of complement for just a couple more your turn problems here, numbers 8 and 9. Remember again, read through your description of your sets very carefully here, and we will see you guys next time.